Hello everyone. In this video, we're going to discuss about how to construct finite automata for the given regular gram. So in the previous video, we have seen that this is the reverse of the previous video. That means in the previous video, so they have given the finite automata. For that finite automata, we have constructed the regular grammar. But now in this video, they will give the regular grammar. For that regular grammar, we need to construct the finite automata. That means reverse process. So for this also we have some procedure. So let's see the procedure first. So let G is equal to VTPS be a regular grammar, we can construct DFA M, right? So states corresponding to non-terminals, this already we know. So states corresponding to non-terminals, that means vertices, both are same. So whatever the vertices you are using in your grammar, so that will be equivalent to your M. That means finite automata. This is grammar, this is finite automata. Then initial state corresponding to state, that means whatever the initial state is there in DFA, that will be the starting symbol. So starting symbol, whatever the starting symbol you are taking, take that as QR. Then transitions in M. So transitions in M are related to productions, right? Already we have seen how to write the productions also for the given finite automata. So now, if there is a production rule, AI tends to A. That means only terminal symbol without any state. That corresponding transition terminates at a new state called QF. See here, why? Because we don't know what is the final state if they provide only grammar. See, what is grammar? G is equal to VTPS. In these four things, we don't have F, capital F. That means what is the final state for that grammar or for that finite automata? We cannot identify directly, right? So that's why what we are doing along with the additional things, along with the provided state. For example, in the vertices, we have three vertices. Now in your final DFA, you will get four states. What are those four states? Whatever the states you are taking here, 3 plus 1 final state. So you're getting one additional final state here. So how to take that final state? So what will be the incoming paths for that final state? So this is the case. For example, if you get any transition like this, so AI tends to A, that means only terminal. If you have only terminal, then in that case, AI on A will go to one state. What is that state? Final state, new final state, right? So in the same way, I have one more thing, BI tends to B. That means from BI on B, it will go to one new state. What is that new state? Again, the same final state. So this is the case, and the final constructed DFA will be in the form of this one. So Q0, Q1, and so on Qn. After this Qn, you're adding one more state, final state Qr. Then this is same as terminals. Whatever you're getting terminals in G, that will be copied as this. So delta is production rules, Q0 is the final state which is same as S in G, and QR. So here we will have only one final state, and what is that final state? Newly created state, that is QR. So now the delta is defined as each production. AI tends to AJ induces a transition, we know. So if the transition is like this, then what is the meaning of this? Qi on A is going to Qj. The meaning of this production rule is Qi on A, it is going to Qj. The meaning of this production. In the same way, each production AK tends to A. So if I have only AK tends to A without any state, then induces a transition from QK, on the input A, and where it will lead? It will lead to the final state, that is QF. So QF with a label A. So the label means the input will be A here, and it will go to final state. So if we don't have any state here, then it should lead to final state, the newly created final state. So these are the rules to construct finite automata for the given regular grammar. So now we'll try to solve some problems. So this is the problem given. So this is the diagram. Directly we have taken the diagram, but we'll try to solve this. Okay. So here first we will write the G is equal to VTPS format. So what are the vertices we have? We have two vertices here, S and A. And what are the terminals we have? Two terminals, A comma B. And production rules they have given, and S is the initial state. So now we will consider In place of S, we will take Q naught. Why? Because it is the initial state. And A, we will take it as Q1. And we will get one more state, QF, which is the final state. Right? So now we will write Q naught. So that means yes on A. Yes, Q naught is the initial state. On A, where it is going on? It is going to S itself. Sorry. On A, it is going to S itself. Then on B, Q naught on B, it is going to A. A means what is the state? Name of the state is A. For A, we have taken a new state called Q1. So Q naught on B, it is going to Q1. Then S tends to B. S tends to B. So that means we don't have any state here. In that case, what I need to do? Q naught on B, it should go to a new state called QF, which will be the final state. So now as transitions are over, see here, yes, I mean Q naught on A goes to Q naught on B, Q naught on B goes to A. A is nothing but the Q1. Then Q naught on B, it is going anywhere, nothing. So it is not going anywhere. That means Q naught on B will go to final state. Now coming to A, A is nothing but the Q1. Q1 on A goes to Q1 itself. Q1 on A goes to Q1 itself. Q1 on B goes to S. So Q1 on B goes to Q0. Then Q1 on A will not go anywhere. That means on A it will go to final state, right? So this is the final diagram for your given regular expression. This is the final finite automata for the given regular grammar. See here in this diagram, they have considered the state names as it is S and A only. So if you want, you can rename them. Otherwise, you can keep them as it is. And the additional state they have added is C, which is nothing but the final state. Right? So here we have taken an additional state called Q. Both are same. Now this is the next one. Next problem. I hope everyone is clear with the first problem. So now here we have four states now. S, A, B, C. First we'll try to construct all these. I'll keep all the states as it is. Okay. No need to confuse. Okay. So S will be the initial state. S will be the initial state. Then S on A goes to S itself. On A it is going to S only. On B also it is going to S itself. So A comma B. On A, S on A is going to A. Now S transitions are over. A on B, A on B is going to another state called B. Then B on A, B on A is going to another state called C. And see, we don't have any transitions here. We don't have any transitions here like in this format, like A tends to B. Without any states on the right side, we don't have any transitions like that. See here, here we have state, here we have state, here we have state, here also we have state, here also we have state. So, but we have C tends to epsilon. One transition is there, C tends to epsilon. That means on C, you can move epsilon to a new final state called QF. New final state called QF, right? Otherwise, anyhow, it is epsilon only. Epsilon means it's nothing, right? Without taking any state, it is moving to another state. Otherwise, simply you can ignore this and you can make your C as final state. Both are same. See, if you are like confusing why we are not taking QF new state for this problem, in that case, you can take QF new state by making an epsilon path here. Otherwise, you can simply remove this epsilon and you can make your C as final state. Okay, but see, just observe in the question they are asking for DFA, but what we are getting NFA. Just observe also. S on A it is going to yes as well as A also, right? So it is NFA, pure NFA. We need to convert this diagram into DFA. Already we know how to convert an NFA into DFA. In the first unit we have discussed that. So using that process, just convert this diagram into DFA. First, observe the question, what they are asking, whether they are asking for NFA or DFA. If it is NFA, it will be fine, this will be the final answer. But if they ask for DFA, we need to convert it into DFA again. I hope this is clear, everyone, right? So why we are not taking this epsilon to a new state, even if you write that epsilon also, nothing will be changed. So directly you can make C as a final state. So if you want, you can keep this epsilon as it is. But they asked for DFA. First, you need to remove epsilon here, NFA with epsilon to NFA, then NFA to DFA. If you don't consider this path, if you directly make the C state as final state, directly you will get NFA, that you can convert it into DFA, which will be the final answer for your problem. So this is the one, very simple. See, as it is, we will take now S and A additional state we need to take if possible, right? So S will be the initial state. S will be the initial state. S on 0 goes to A. S on 0 goes to A. S on 1 goes to S only. And S on 1. S on 0, S on 1. So S tends to 0 is there, S tends to 1 is there. That means it is not going anywhere. Then we need to move it to 0, comma 1, move it to a new final state called QR. Then A on 1 is going to A itself. Then A on 1 is going to S on 1 only. A on 1 is going to A as well as it is going to S also. Then simply A on 1, it is not going anywhere. Then you need to move it to final state. But if you observe this diagram, this is a NFA diagram which we need to convert it into DFA. Why? Because in the question they have asked for TFA. I hope this is clear. And this is only one problem, homework problem. Just follow the process, given process, and try to construct DFA for this. I hope everyone is clear with this video. Thank you.